Okay, moving on from chapter 4.6 to chapter 4.7. We'll spend a couple days on 4.7. Transformations of polynomial functions. This will be part 1 today. So, have we talked about transformations before of other types of functions?
I think so.
We have. We've talked about transformations before. So, this is just pretty much an extension of that. We're just dealing with polynomial functions. You can transform graphs of polynomial functions in the same way we transformed graphs of linear functions, absolute value functions, and quadratic functions. Examples of transformations of the graph of f of x equals x to the fourth are shown on the next slide. So it's still, you guys remember those formulas we had for our transformations?
No.
Like f of negative x and negative f of x. And f of x minus h, a times f of ax, all that fun stuff last semester. Hopefully some of you somewhat remember that. If we don't, we'll look at it. F of x plus k, all that good stuff. So, f of x equals x to the fourth. Here's a bunch of transformations that we could do with x to the fourth. Okay? Like I said, it is the same formulas that we had back in chapter, I don't even remember what chapter it was, but last semester when we talked about transformations. The f of x minus h, f of x plus k, f of negative x, negative f of x, f of ax, and a times f of x. Okay? So, you should have that chart somewhere in your notes. If not, you probably want to get it down in your notes. So you have these formulas. So that way you know which formula to use when it's talking about certain transformations. Yeah, I'd have these formulas written down. And what they are. I would write those down. So I'll erase these lines, get them out of your way. They use the example, f of x equals x to the fourth. So, if it's a horizontal translation, we're using f of x minus h. Okay? F of x minus h. Say it again.
That's an h.
Right here is an h. F of x minus h. So, if it tells us that it's a horizontal translation, 5 units to the right, 5 is my h value, so I plug 5 in for h. So I have f of x minus 5. I plug x minus 5 in for x. I get g of x equals x minus 5 to the fourth power.
We don't need to write through that example now, do we?
You can if you want, but I'm going to be moving on here pretty quick after I'm done going through it. This chart is directly in your book, though. It is in your book.
Is that a K on the second one?
Yep, okay. If it tells me I'm translating 2 units to the left, that's a negative 2, because left would be negative. I'm going negative 2. So I'd plug negative 2 in for h. If I have a subtraction sign right by a negative, it turns to a... If I have a subtraction sign right next to a negative, it turns into a positive. So it'd be f of x plus 2. So I plug x plus 2 in for x. And I get x plus 2 to the fourth power.
On horizontal stretch or shrink, is that f of a and a?
F of ax. F of a times x.
What's the third one?
The reflection, f of negative x and negative f of x.
So, when it says, it says x plus 2
To the fourth power.
to the fourth.
Yep, because if it's telling me it's a translation 2 units to the left, my h value is negative.
Plus.
Say it again.
If it's plus, why is it going one?
I'm about to explain it. Okay. It's f of x minus h, correct?
Yeah.
2 units to the left would be a negative 2, because we're moving 2 units to the left. Right? It'd be a negative 2. My h value is negative 2. So if I plug negative 2 in here for h, I get f of x minus negative 2. Subtraction sign right next to a negative makes a... That's why it's f of x plus 2. Okay? That's why it's plus 2. And if we're going right, it's minus 5. Vertical translation, if I'm going 1 unit up, my k value is positive 1. So I plug 1 in for k. So I'm doing f of x plus my k value. So my function plus 1, so that's x to the 4th plus 1. If I'm going 4 units down, that's a negative 4, that's my k value. So I plug negative 4 in for k. Doing f of x, my function, plus negative 4 or minus 4. So x to the 4th minus 4. Reflections. If I'm flipping it over my y-axis, reflecting over my y-axis, we use f of negative x. So I'm replacing x with negative x. If I have a negative x to the 4th, that's just x to the 4th. So that one doesn't change. If I'm reflecting over my x-axis, it's a negative f of x. So I'm making my whole function negative. So that'd be negative x to the 4th. Because there's my function that I'm using, right? F of x equals x to the 4th.
What's that for?
That's the function they're given examples for. These are all transformations of that function. Horizontal stretch or shrink. It's f of ax. So if it's a shrink by a factor of 1 over 2, my a value is 2. Because remember, back last semester, if it's a horizontal stretch or shrink, it's by a factor of 1 over a. So my a value here is 2 because it's 1 over a. So it'd be f of ax, which is 2x. So I plug 2x into my function, I get 2x to the 4th. If it's a stretch by a factor of 2, 1 over a, I get 1 half. Plug 1 half in, 1 half x in for x, I get g of x equals 1 half x to the 4th. And lastly, the vertical stretch or shrink. A times f of x. So if it's a stretch by a factor of 8, plug 8 in for a. So 8 times my function would be 8x to the 4th. Shrink by a factor of 1/4. 1/4 is my a value. So 1/4 times my function, 1/4 x to the 4th.
This is a times f of x. So that's it.
Yep, very bottom, a times f of x. So if it's in parentheses, I'm doing something to my inputs. And if it's outside the parentheses, it's doing something to my outputs. But these are the same formulas we used last semester. So you should already have them down somewhere in your notes. But if not, you should have written them down today. We're going to be using these to describe transformations of our polynomial functions. Any questions? We're still writing? I'm going to give you just a little more time. Tad bit more time. So, when we have stretches and shrinks, if it's by a number that is bigger than 1, it's a stretch. So, here we have it as 2, so it's a stretch by a factor of 2. Here it's stretched by a factor of 8. If it's between 0 and 1, it's a shrink. Shrink by a factor of 1/4, shrink by a factor of 1/2.
It's
And if it's,
like that's the opposite.
say it again.
Like that's opposite.
Right, so back whenever we talked about this last semester, when we have horizontal stretches and shrinks, it's by a factor of 1 over a. Okay? So if my a value is 2, 1 over a would be 1/2. Right?
2 over, yeah.
Because the a value is 2, 1 over a, 1 over 2.
So you,
By a factor of 1 over a, if I have 1 over
it'd be 2 over 1.
1/2, that's dividing fractions. That's 1 over 1 divided by 1/2. KFC, keep the first one the same, flip the second one, change from division to multiplication, that's 2. So that's why it's by a factor of 2. Okay?
Yeah.
Now, when I have vertical stretches and shrinks, it's just by a factor of a. So if I have g of x equals 8 times x to the 4th, what's my a value?
I don't even know. 8.
8, so it's by stretch by a factor of 8. G of x equals 1/4. It's my a value,
4.
1/4,
I don't think.
because it's being multiplied by the function. That's a shrink by a factor of 1/4. Okay? Hopefully I answered your question somewhere in there. Okay, I am moving on. Like I said, this chart is directly in your book. And you can always go back and watch this video again and get the rest of the chart written down if you didn't get all of it. Okay? So example 1. Describe the transformation of f of x equals x cubed represented by g of x equals x plus 5 cubed plus 2. Then graph each function. Okay? So,
This doesn't make sense.
yes it does. I'm about to explain it a little better. Hold on. We haven't even gotten into it. So, the function g of x over here is a transformation of the function f of x. So I've got to figure out what transformations are occurring here based on what's going on in the parentheses, outside the parentheses, so on and so forth. And we're going to be looking at all these formulas right here. Okay? So, inside the parentheses, I'm adding something to my x value, correct? Correct, right? I'm adding something to my x value inside the parentheses. Which of these formulas are you adding or subtracting something inside parentheses? Horizontal translation. Does everyone see that?
Yep.
So, remember, if it's inside, we're kind of doing the opposite of what our signs say. So, if it's a plus 5, it's a horizontal translation, but am I going left 5 or right 5?
All right.
Left, because remember, it's f of x minus h. So my h value is negative 5, but since it's minus the h value, minus negative 5 would turn to plus 5. Does that make sense? So I'd say g of x is a horizontal translation
5 units to the left.
5 units to the left. Everyone okay with that? The horizontal translation part? Okay. I'm also adding a number outside of the parentheses. So which of these formulas looks like we're adding or subtracting something outside the parentheses? Vertical translation, right? Here, do I follow the sign or do the opposite of what it says?
You follow it.
Follow the sign. So if it's plus 2, am I going up 2 or down 2?
Up to.
Up 2. And a vertical translation 2 units up. Are those the only 2 transformations occurring here?
Hopefully.
It is. I can tell because do I have anything being multiplied outside the parentheses?
No.
No. Was x multiplied by anything inside the parentheses?
No.
No. Do I have a negative outside my parentheses?
No.
No, so it's not a, what's the word? Or reflection. Is x negative inside the parentheses? No. So I can tell based on these formulas, I had something inside the parentheses adding or subtracting, so it's horizontal translation. I had something adding outside the parentheses, so that's a vertical translation. I didn't have negative x outside or inside the parentheses, and I didn't have my function being negative. I wasn't multiplying x by anything inside the parentheses, and I wasn't multiplying my function outside the parentheses. So I know those are the only 2 transformations going on. Everyone okay with that? Does everyone still understand why it's 5 units to the left and not to the right? Because it's f of x minus h. 5 units to the left is negative 5. But if I plug negative 5 in here, x minus negative 5 turns into x plus 5.
It's going to be the opposite.
Inside parentheses, it will be the opposite for adding and subtracting. Okay? So if this was x minus 5, I would have gone 5 units to the right. Outside the parentheses, you follow the signs. Positive 2, you're going up 2. Minus 2, you'd be going down 2. Everyone got that? Okay. What else does it want me to do for this problem? Graph each function. This is where our graphing calculators come into play. Now, last year when I taught Algebra 2, I had us use a table of values to graph these. This year, I'm letting you use the graphing calculators, and we're just going to draw a sketch of our graphs on our paper. Everyone okay with that?
Sweet.
So, I'm going to type in f of x equals x to the third. Does everyone know how to do that on their graphing calculators?
Let's see. Where's F at?
Okay, hold on.
We have used the alpha.
So turn it on. Turn it on. And you should see a blank screen with a blank or a blinking cursor. Right?
Yeah, buddy.
Okay, to get to the where you type in the equations, hit the y equals button in the top left. Y equals, and a bunch of y equals should pop up. It should say y sub 1 equals, y sub 2 equals, y sub 3 equals, so on and so forth. We're going to stay in y sub 1 and y sub 2. So in y sub 1, we're going to type in x to the third. So, you see the green alpha key.
Yeah.
Hit the green alpha key. And then does everyone see the green X above the STO button? Lower left.
Yeah.
So I got to hit alpha so I know I'm doing the variables. And hit that STO key and you should see X pop up on your screen.
How do you do it?
Jeremiah, you wait. We're typing in these calculators. Now see, we're typing in these calculators. You got it?
Yeah.
What's up? Top left.
Where's the equal sign?
Does everyone have an X on their screen?
It's
Well, no.
Okay. We now need to get an exponent of 3. We have this little caret key on our calculators that looks like this.
Uh-oh.
That is kind of middle right, below the clear button.
Above the division.
Everyone see that? Above the division sign. Click that, and an exponent box should pop up with a blinking cursor. Everyone got that? And then type in 3, so we get an exponent of 3. So everyone should see y sub 1 equals x to the third.
Yeah.
Everyone okay with that? Okay. Hit graph. Top right button.
Ooh. Did you see it?
That's sick.
How does it know?
Everyone got that? So, on your paper, I'm not even going to require you to label your axes or put numbers on here or anything. I just want you to draw the y-axis and the x-axis on your paper. Can everyone do that for me? And then sketch what the graph looks like from your graphing calculator.
That's what it's supposed to, that's the answer to everything we just did.
Mine keeps doing this. That's crazy for real.
Yeah, mine's crooked. It's not going to be perfectly straight. Get it as close as you can. Okay? So I graphed the first one. Now I got to graph the second one. So get from your graph back to the y equals, hit y equals.
Do it clear or go to Y2?
Go to y2. Click the arrow down to y2. So y2 equals. And now I'm going to type in this polynomial function exactly like it is, including parentheses and everything. Okay? Everyone with me? Everyone with me? So type in your parentheses. Use that alpha key to get x again. Plus 5. Close your parentheses.
Wait, how'd you get, where's the?
How'd you get back?
Click the y equals.
Where's the parenthesis at?
It is above 8 and 9.
Wait, those aren't parentheses,
Yes, they are.
they're like brackets.
No, they're parentheses. Okay, we're going to have to use that caret key again after we close our parentheses. So hit the caret key and type in 3 again. Now this is important. After you hit the 3 button for the exponent of 3, I need to click my arrow to the right to get out of the exponent space. Does that make sense? If you keep typing from there, it's going to type in 3 plus 2 up in your exponent. We don't want that. We want x plus 5 to the third power, all of that, plus 2. And then once you get it typed in exactly as it is, hit graph again. And it should pop up on the same graph that you have x to the third. Does everyone see that? So from your graph on your graphing calculator, you can tell that the graph of x to the third was shifted left 5 and up 3 units, and that's my new graph. Does everyone recognize that?
It's 6, not 5. It's 6.
Mm-mm. Oh, it's 5.
X plus 5.
There's 2, not 3. I might should be.
You got
Draw your graph the best you can. I'm not the best at drawing them, but it should be pretty dadgum close.
That's not pretty darn close.
Yeah, it is.
That's pretty daggum straight.
Coach Matt,
Here we go.
That's pretty
did you take art in high school?
pretty nice.
Yeah, I wasn't very good at it.
You can tell.
Is that better?
Sure.
Okay. Okay. Does everyone understand what we're doing?
Look how good mine was.
Listen. You're describing the transformations that are occurring, graphing them on your graphing calculator, then sketching the graphs on your paper. Everyone okay with that? This goes a lot faster than creating a T-chart, graphing each T-chart, all that good stuff. Can I move on?
No worksheet.
Okay. Describe the transformation of f represented by g, then graph each function. So we're doing the exact same thing we just did,
Why is there a comma?
because it's separating the two functions.
That's crazy.
So I've got f of x equals x to the fourth. G of x equals negative 1/4 x to the fourth.
Coach Mikey, I have one of these in my own version.
Graphic calculator?
Yeah,
Cool. Yeah, you can use it if you want.
this one.
Wait, can you read it again?
F of x equals x to the fourth.
Let's see if it works.
G of x equals negative 1/4 times x to the fourth.
Must be dead.
Okay, so we got to describe the transformation first. So G of x is a transformation of f of x. So I got to figure out what they did to get from f of x to G of x.
Well, they just
Okay, so let's look at our chart over here. Am I adding or subtracting anything inside parentheses with x?
no.
No. Am I adding or subtracting anything outside of parentheses?
No.
No, I'm not. Okay? Do I have a negative inside parentheses or outside of parentheses?
Yeah.
Yes, I do. So is this a reflection over the y-axis or over the x-axis?
X.
X-axis, because my negative is outside grouping symbols, correct?
Yeah,
So I'll say g of x is a reflection over the x-axis. Everyone okay with how I got that transformation?
yeah.
And then I've got 1/4 times my x. Is that in grouping symbols?
No.
No. So it's a times my function. Is that going to be horizontal stretch or shrink or vertical stretch or shrink?
Vertical.
Vertical stretch or shrink. What is the factor? What's my number that is being multiplied by?
1.
1/4, right? Is that greater than 1 or between 0 and 1?
That's like between 0.
Between 0 and 1, so it's going to be a vertical shrink by a factor of 1/4. Are those the only two transformations occurring? Yeah, they are.
Can you go back to the...
Because we already eliminated that it's not a horizontal translation, it's not a vertical translation. So it is a reflection. It's not a horizontal stretch or shrink, but it is a vertical shrink. Yes.
So a shrink is one is between 0 and 1.
Vertical shrink, yeah, between 0 and 1. And then vertical stretch is if your A value is greater than 1. And then for horizontal stretch or shrink, if your A value is greater than 1, once again, it's a shrink. But it's a shrink by a factor of 1/2 because it's 1 over a. And then if your a value is between 0 and 1, that'd be a stretch, horizontal stretch by a factor of 1 over whatever that fraction is. Okay?
So there's only like a few numbers that go between 0 and 0?
Like 1/2, 3/4, 1/4, 1/5, 2/5. There's a lot of numbers between 0 and 1. So those are the only 2 transformations, correct?
Yeah.
So now I can graph them. Pull out your handy dandy graphing calculator. Hit y equals again. And go in and clear out y1 and y2. So you have room to put these 2 new polynomial functions. Okay? So let's type in x to the 4th first. Does everyone remember how to do that?
Second,
You're going to have to hit alpha, and then that STO button to get x. And then you got to hit your caret key to get an exponent of 4. Once you type in x to the 4th, just like it is, hit graph.
oh, whoops.
What is yours? What is yours?
So I'm getting something that looks like this.
So wait, what do you put in for the second one?
Does that look similar to your guys's?
Oh my, no.
What does yours look like, Trey?
Oh, that's
A
usually
lot better
worse.
than that.
Huh?
You did that worse.
I know I did. Let's fix it.
Yeah, fix it.
Shoot. I clicked a button and now how to go back.
That's a lot better, but your arrow is too high. It's
That's okay. It's okay.
It's okay.
I'm going to leave it.
It's okay.
Okay.
There's no back button.
Now, hit y equals to get back to the y equals screen. Go down to y2. And now I'm typing in negative 1/4 x to the 4th.
Mine says error.
What?
I tried to do it.
Let me see.
Air. Where's
Are you using your personal one?
Yeah. Actually, I didn't know how to put it in.
But where's the
One
fraction
before.
one?
Okay.
So I put one around.
So, these don't handle fractions like these over here. Here's how we got to do a fraction. Here's how I would type it in your calculator.
voice activated? What?
Put the dash.
You'll put the division symbol. 1 divided by 4 in parentheses. Because that's what a fraction is division, right? So put the negative sign, parenthesis, 1 divided by 4, close your parenthesis, x, exponent of 4. And that's how I would type it in your calculator, just like that.
Oh, we're going crap.
And graph it.
Error. Error.
Error.
Syntax. 1, quit. 2,
That's what happened.
go to.
So we said it was a reflection over the x-axis. It did reflect over the x-axis, correct?
Yeah.
It's a vertical shrink by a factor of 1/4. So you may notice your graph got a little wider because it shrunk vertically. It squeezed it in more.
That graph gave me a syntax error.
I got mine on.
So there would be my sketches of my graphs. Are there any questions about what we're doing here?
Question?
What's up?
Are you in a subtraction sign? Yeah. There's a negative one.
Too much talking.
Oh, I see it at the bottom.
Everyone okay?
Let's see.
Okay, let's do our last example here. Letter B. Carter, I'll come look at yours here in a second.
Oh, I didn't put the parentheses.
Okay, B. F of x equals x to the 5th. G of x equals 2x to the 5th minus 3.
You said 2.
That's not one.
Yeah, that one.
Well, can you go back to the
I'm about to. I'm letting people write it down first.
The one that, where you can't subtract outside the parentheses. That one, right?
Hmm?
The one where you can't subtract outside the parentheses.
What do you mean can't subtract outside the parentheses?
Well, I know you can, but because there isn't, it's something, right?
There are some transformations occurring here, so I'm going to go ahead and write out g of x is. Okay, let's go look at our chart.
You're gonna need to know how to.
Am I adding or subtracting inside the parentheses?
I can't remember.
Yeah, so that,
It is
Wait, say that way. Say that again.
2x
No.
to the 5th minus 3.
It's a vertical translation.
Am I adding or subtracting inside the parentheses? No. So is this a horizontal translation? No, it's not. Please quit talking. Am I adding or subtracting outside parentheses? Subtracting, right? So it's going to be a vertical translation. How many units and which way am I going? It's a minus 3. If it's vertical, it's either up or down. Down how many? 3 units. Very good. So g of x is a vertical translation. 3 units down. Bless you. Everyone okay with identifying that vertical translation? 3 units down. Let's go back to the chart. Do I have a reflection? Do I have negative inside the parentheses or negative outside the parentheses?
Yes.
a negative
Where?
outside.
Outside.
Where?
Subtract 3.
I already dealt with minus 3.
Since when?
I said that was a vertical translation 3 units down.
But, then, what?
Do I have a negative immediately outside the parentheses to the left of that 2x?
No.
No.
That, if that was the case, it would have looked like this.
I don't care about.
Negative 2x. You know what I mean?
I know what you mean.
So, do I have a negative inside or outside the parentheses?
I do not believe you do.
I do not. So I do not have a reflection over the x-axis or the y-axis. Okay. Am I multiplying x by anything inside the parentheses?
By
Yeah.
2.
By 2, right? So this is going to be a horizontal stretch or shrink. Remember, horizontal stretches and shrinks are by a factor of 1 over a. So what's my a value here?
2.
2. So 1 over 2 would give me
1/2.
1/2. So this is going to be a horizontal shrink
By a factor of 1/2.
by a factor of 1/2.
So, you just put the 1 over whatever
Wait.
number that is in there? Goes back.
Hold on one second.
What's
Does everyone see that? Do I have a vertical stretch or shrink? Am I multiplying by any number outside the parentheses?
No.
No. So there's only 2 transformations going on here. Correct? Vertical translation and horizontal shrink.
Your handwriting
Sorry. You'll be okay. Okay. Then I would graph these. Are we okay graphing wise?
Yeah.
Graph them in your graphing calculator. Draw a sketch on your paper.
Hold on.
Okay?
Can you go back to the graph one?
There.
Yeah. That one.
So x to the 5th.
Wait, is it my calculator's not working?
That's what you get.
So it'd be x to the 5th.
I saw you driving
You should wear.
Wait, that's the same thing as
So there's my graph of x to the 5th.
You're on 15.
So it'd be 2x to the 5th minus 3.
A little later today.
Oh, wait. You can pick.
Wait, that's so weird.
So we said it was a horizontal
No, this is crazy.
shrink. So it shrunk horizontally. So it got skinnier. And it got translated down 3 units.
Yeah, I got that.
Awesome.
Me and Nathan are rocking
So that'd be roughly what it would look like. Okay, like I said, it's not going to be perfect. Do your best to draw it. Just sketch it on your paper. Questions?
I feel like you don't even try to draw.
Here we go. Here's your assignment. Page 217, 1 through 15 odds.
There's 217, 1 to
It's like what? 7. No, that's
It goes
1, 3,
around.
5, 7, 9, 11.
My
13,
team won
15.
the World Series.
It's 8 problems. It's not bad. So, draw. Actually, write this on your paper as well.
December.
Desmos.
Oh, I love that.
That is a free online graphing calculator that can help you do your assignment because you're not taking these home with you.
For what?
So go to Desmos. It should be the first thing that pops up on Google. You can type in the functions just like we did here, and it'll graph the functions for you. So it'll help you draw your graphs on your paper. We good? Any questions before I end the recording?